welcome back to Soundbites of the annual meeting here on the floor at ASGCT. My name is Ben McLeod from Convey Bio, and today I'm joined by Hans-Peter Kiem. Thank you so much for being on.
Happy to do it.
Excellent. Yeah, so we understand that you just won an award today. Congratulations. Can you tell us a little bit more about that?
Yeah, it was the George Stamatoyannopoulos Mentorship Award, and of course named, for the late George Stamatoyannopoulos, and that means a lot to me. As I said earlier in my little speech that I gave, because he was instrumental in mentoring junior people, trainees, and that's really been one of his biggest vision, and he felt very strongly about that. So this was a very important award for me, and I've of course known George for a long time, since founding the ASGCT, the American Society of Gene and Cell Therapy, in 1996. I've worked with George, so that's why it meant a lot to me.
Excellent. Fun fact, I was born in 1996.
There you go.
I am the same age as ASGCT.
That's right. Exactly.
Excellent. So yeah, I'd love to learn a little bit more about your therapeutic focus.
So I am, of course, this is a gene therapy society and a cell therapy society. I've started out with gene therapy, of course, for blood diseases. So we've been using different kinds of vector systems to modify blood cells to correct blood cell diseases such as hemoglobinopathies, sickle cell disease, for example, thalassemia, but also other genetic diseases. And that's really how we started out, using typical vector-based gene therapy, but then more recently, of course, also over the past 10 years, a lot of the gene editing.
Excellent. And with regards to where you see the industry going, right? You've been coming to the meeting for a long, long time. I would be curious to get your thoughts on kind of where do you see the industry moving over the next 5 years? Is there anything that you think isn't getting a whole lot of attention right now that you think will be a lot larger in 5 years from now?
Well, I think we're seeing some of that trend. Some of my research, as I mentioned, was for genetic diseases, so stem cell-based gene modifications. But of course, over the past almost a little bit more than 10 years, there's been a lot of interest in also modifying T cells, harnessing T cells to become CAR T cells, cancer-fighting T cells.
Right.
So that, of course, also requires gene therapy, because here we modify the T cells. And so far, we've all done this ex vivo, so outside the body, in the most cases, which is, of course, a very large and big process. We have to take the cells out from the patient, bring them to a facility, modify them, correct the defect ex vivo, and then infuse them back into the patient after conditioning. So that is a lengthy process, very expensive. We've started very early thinking about in vivo delivery. That means modifying the cells directly inside the body. So we would only deliver a vector-based system. Very often we call it virus-like particle, and then harness that particle to modify the T cell or B cell or stem cell directly in the patient. For example, for T cells, of course, we would then harness the particle to find the T cell and then introduce the CAR, chimeric antigen receptor, directly in vivo inside the body of the patient, versus taking the cells and doing all this in some facility.
Yeah, for sure. Yes, the great in vivo versus ex vivo CAR debate. Where is it going to go? But I'd say there's still going to be room for both, right? There's going to be some approaches where...
Absolutely, there's going to be room for both. No, we're just at the beginning for the in vivo. That's very important. But I'm so excited that we are in the clinic, and there's companies interested. You asked me about where this is going. And I do think, yes, it has to be optimized. But I do think this is where we hopefully will be able to go.
Excellent. Hans-Peter, thank you so much for your time, and congratulations once again on winning the award.
Sure.